Yes, good morning all. Today we will learn about the TKGate, and TKGate is a software or you can say tool by which you can design the you can say digital circuits, and then test also verify whether the functionality by it is working properly or not. So these two things you can do by the simulation kind of things. Okay, so now how we can start? You have to install the ubuntu. On ubuntu, open the terminal, and then you have to install uh, by sudo apt update command. So first you have to apply this particular command, then your ubuntu will be updated as per the new you can say new version. Then you have to install TKGate by install TKGate. Okay, so use this particular command, and this command basically will install the TKGate. Okay, so now because I have already installed the TKGate, so let's start with the TKGate itself. So TKGate. So when you run this particular command, it will open this particular window. Now, file, new. Okay. So first we understand that what are the you can say options are available. Here basically three things are given in this particular part. First is editing, where you can design your own schematic or you can say a logic diagram. Interface, if you are using some kind of modules, we will learn that what is the meaning of the module. So that particular part. And simulate, that you want to test whether this particular circuit is working properly or not. So that particular part we can test through the simulate button itself. Now editing, what are the options are available, or what are the different elements available. So when you right click it, then you will find that component. IO component means input output component, switch, dip switch, concat, LED bar, 7 segment LED, all these are available. Even the clock is also available. All these are the input output. So first three are the input component, these are the output, and this one is the clock. Similarly, gate also multiple type of gates available, and or not, XOR, even the tri-state gate or you can say tri-state buffer is also available. If you want to design a CMOS circuits, in that case PMOS and NMOS is also available. Then this is the reduction, MSI, the multiplexer, demultiplexer, decoder, whatever the combination module we have learned. Then the ALU is also available, adder, multiplier, divider, even the shifter is also there, left shift, right shift, arithmetic right shift, or road message is a kind of a cyclic shifting. Okay. Then the memory elements, so the base memory element is D flip-flop. So 1 bit if you want to store, so 1 bit you can store in the D flip-flop itself. The reverse D flip-flop, register, JK flip-flop, reverse JK. So in case of the register, what happened? It's a collection of D flip-flops. Okay, that we have already discussed in the sequential circuits, sequential modules itself. Apart from this, a combined module is also available for RAM and ROM. So, like through the D flip-flop, you can design your own register or RAM and ROM also. Similarly, you can design your own customized circuit using the modules. Other than that, the signal, a pull-up, ground, VDD, pull-up. So all these are circuits are available for CMOS-based circuit design itself. Okay. And then the tools which is available, move and connect. So initial for design part, you have to use this move and connect. Cut wire, if you have mistakenly connected with some other component, then you can cut through this particular part. Invert, so if the, let's say, AND gate is you have used, or now you want to convert AND gate into NAND gate, so that invert, you can say invert sign will be specified by this particular tool. And that this is bit width, you want to change the bit width to a very specific one, that also you can use. Okay, let's see that how to design a simple circuit. So first is input. Okay, one more thing, that you can zoom this particular circuit using this zoom in. Okay, these two. So these are the switches. So it means you can pass the 0 or 1 input. Let's say I will use AND gate, gate, AND gate, and output we can check on the LED. So whenever you want to connect, so use this edge of this particular wire. When you click here, then you will find that there is a soldering iron signal is there. Only in that case you can connect with the other one. So on the edge of the other wire you can connect it. Similarly like this one. Similarly like this one. You can check also whether it is working properly or not, whether it is connected or not. When you drag this one, then you will find that it is connected. Now, now your circuit is ready. Now you want to test. So simulate. The simulation mode has started. Now you want to run. So press the run button. Run simulator. So yellow sign says that it is not yet started, or you can say, so you have to use the run button. You have to press the run button. Now because it's the AND gate, so both inputs are on. Only in that case the LED will glow. Okay, otherwise it will not glow. So this is a simple way we can start the simulation. Another one is, let's say we want to design. Okay, we want to how to cut the one. Just a minute. So in this tool you can uh, connect this part also. Similarly, tool move one. Okay, let's try to design the CMOS gate circuit. For CMOS, you need the PMOS and NMOS. PMOS is in the this sign. Just a minute. Okay, we have learned that PMOS and NMOS. The PMOS is connected on the VDD, so we need the VDD also. Signal VDD. Similarly, NMOS will connect with the ground. Signal ground. Now connect it. Okay, if you want to connect multiple points, in that case you have to add one wire segment, and now you can connect. Similarly here also one wire segment, then you can connect here. Now LED how we can connect, just a minute. Okay, so now all are connected. Now we can test it. Simulate, yellow light, run. So if both are on, only in that case it's off, otherwise on. So this is which gate? NAND gate. So in this way we can design the CMOS based circuits also. Next. Okay. Uh, let's say want to use the modules. Just a minute. Connect. How we can design a module instance. We have to put the name, let's say half adder. Okay. Okay. So inside this module you can design your own circuits. So how we can design? Open it. Now you can design let's say AND gate. It's the XOR gate. Because it's a module you can think of like a chip. So inside the chip you cannot have the switch. So we have to pass the input from the outside the chip itself. So for that one, you need the module input. Module output. Okay. Then this way we can connect. Add wire segment. So actually this one is you can say carry, C out. And this one is sum, hide name, and then sum. Similarly here the two components. Now close it. Then now we have to define that how we can insert these we can say input signal and output signal. We can take the output signal. In that case you can go to the interfaces, open interface, add it. And because right now it is not visible here, so we can say the synchronize all. So whatever we have defined inside, it will synchronize and it will create the one. Just synchronize all. So when you go to the editing part, just a minute. Auto generate. generate. Yeah, auto generate. So now you can see from here, and then synchronize all. First auto generate and then synchronize all. So whatever we have defined, now it will be available in this particular part, and then you can access from outside also. You can see from here, and then you connect. Okay, let's try whether it's working properly or not. Simulate it. So because this is sum and so A and B, and then it will give you the sum and out. So if 0 0, oh, first we have to run 0 0 0, so 0 0, 1 0, so sum is 1 but carry is 0. Similarly here also you can find that sum is 0, carry is but both are 1. In that case carry is 1 and sum is 0. Clear how it is working? Just a minute. So in this way we can design the module. Now, okay. So this is over. Now, how we can check? Uh, okay, one more thing. Let's say input. Input is, let's say, in the switch we have seen that input is a 1-bit input. Okay, but let's say we want to give the multi-bit input. In that case, instead of the switch, you have to use the dip switch. Dip switch. Right now you can see that the 8-bit input you can insert, but you want to change, you can change from here itself bit width. Let's say 4-bit. So yeah, dip switch. Let's say you want to change the number of bits. Four. Okay. So 4-bit input is there. So even instance property we have changed from here itself. Port and 4-bit. Now I want to extract all these bits one by one. So how I will extract the bit one by one? So in that case, IO concat. Okay, here let's say you want to rotate also. For rotation also, the tool is available. So this tool is for the rotation. The input is this one, and this one also we want to rotate. Let's say like this, and this one is 4-bit. Still it is a 2-bit is available, so now you can add the port. Now 4 ports are there. Now we can add with the LED, let's say LED. let's say we want to pass, so in this way we can connect. um, we can design in this way, just a minute. You can make the alignment also. So using this one, align horizontally, and this one is aligned auto vertically. Okay, so let's say we want to simulate it, run it. Let's say we want to pass the value 5. 5 means 1, because it's a zeroth bit is this here, 1, 2 and 3. So when you apply, so 1 0 1. Okay, so in this way we can write down. We can concate the, you can say, multiple bits in a single bus itself. Clear? Now editing. Rotate. So we want to pass the 8-bit value. No, 4-bit we will check. Okay. Now again, now we can use the modules also. So let's say example is adder. So ALU, let's adder. Now we can connect it. Just a minute. 4-bit adder. Make compatible, only in that case it will work properly. Now we can connect it. No, it is not yet connected. Just a minute. Still not connected. Just a minute. Okay. But, oh, why it is not connected? Because it's a 8-bit. So we have to first change to 4-bit. 4-bit. Okay. Similarly, here also output is 4-bit. Only in that case it will connect, otherwise it will not get connected. Now it is connected. Output, again, as I told you that we can use the dip switch. Four bit. Then the carry in, carry out. Carry in will be through the switch. Carry out is with the LED. Okay, now simulate it. Run. So let's say we are passing 2, oh sorry, 3 plus, oh just a minute. Output we have to check on, not on the switch, but it's LED bar. Yeah. LED bar. This is the LED bar. Again we have to change the port. Now it is connected. Let's check whether it is working properly or not. No. Let's say we want to pass 3. 3 plus 0 is 3. So you can see from 0, 0, 1, 1. 6, 7, apply. 7 plus 3, 10. So 1, 0, 0, 1. If carry is also there, then 1, 0, 0, 1, 0. 11. Okay. Now let's say we want to store the output value in the, let's say, register. So in that case, how we can take care. And also you can check that what information is you are passing. That also you can check through the LED bar itself. Again, 4-bit. Now connect it. You can check also. Run it, the 3, and let's say 6. Apply. So this is 7, 7 plus 3, 10. So 10 here and 11. The carry is also there. Clear this point? Now next thing is that how to use the register. On the same manner, yes, you can use the flip-flops also. Again, it's 8 bit, so we have to change. A bit. Now you can connect here. This also you can connect. And then if we can pass the clock, so clock speed is very high, so you can not actually visualize that whether it is working properly or not. Okay, one more LED bar we will add here. Just a minute. LED bar. 4 bit, so that whatever the output it is coming, you can see from this particular one. Then instead of clock, we can pass through the switch also. You can use a clock, so clock is available here, you can see. But right now we are using switch so that we can easily visualize. Enable, we can use the signal ground. Clear 0, so we can use one switch. Okay, let's test whether it is working properly or not. Simulate it, run it. So right now we are passing 0 0. Now we will change 4. So 4 plus 0 is 4. Similarly, let's say B. So 4 plus 9, here you can see uh, is 13, so 13 will be displayed in the net one. Now still this is not inserted in the register. So to insert into register, we have to on this part just a minute. Now it is clear, so no, so clear bar means you have to on. The next clock cycle, the data will insert it into the register and it will shown in this part. So let's say if I change the value, let's say 7 or 8, you can see right now both are same. But let's say new value comes. So in that case, the input is this one. There is a carry. Output is this one, but it's still not gone to the register inside. So next clock on cycle means rising is it will insert into the flip register. You can see from here. Okay, so same way you can use any other modules also. Uh, Switch, dip switch, concate, LED, all these one gates also, multiplexer, decoder, demultiplexer. Uh, okay, I will give one more example. Just a minute. So let's say uh, multiplexer, 4 input multiplexer. So 4 inputs, so we'll, yeah, we'll pass here in this way. So input, let's say switch is there, so 4 switches will be there, and one selection input, so dip switch. Number of port is 2. Then we can start connecting. In this way we can connect it. Similarly, LED also. So how many bits are there? 0 to 3, 0, 1 to 3, and from here we can select that what input you have to transfer. Let's try, simulate it. Done. So let's say 2. So 2 means 0, 1, 2. Whatever be the input here, it will go into the output. So like this one. And there is no change in the other input if there is a change in another input. So it will depends on this particular part itself. Let's say we want to change this switch for 8-bit or maybe for 4-bit. That is also possible. You can end the simulation. Tail ports. Let's say 4-bit we want to transfer. Okay. 4-bit. So input size is 4 bits. So how we can use the multiplexer for that one? That's it. Similarly here also, instead of LED bar is required. 4-bit. Bar graph. Okay. Now still simulate. Run it. Let's say again 3. Apply. So whatever the input in 3, it goes into the output. Oh, we will to change to just a minute. Here we need the dip switch. Just a minute. Dip switch. Rotate it. Now you have to change the input type from 8-bit to 4-bit. This one also 4-bit to 8-bit to 4-bit. Bit. Still not connected, just a minute. Dip switch, orbit, yes, simulated, run. So we pass, let's say 3, and if I want to change the value, let's say 2, apply. So 2 will be pass. So multi input, you can say multiplexer also we can design through this particular part. Okay. So in this way, you can use multiple tools to design this part. We can use the RAM and ROM also. Similarly, D and JK flip-flop also. So ROM is looks like this one. 8-bit. We can change from 8-bit to 4-bit. This side also 4-bit. And 4-bit output. That you can see an LED bar. 4-bit we have to change here also. Now you can connect. And this is enable. You can use not of enable means if you pass 0 then it will enable. So in this way you can run. Now just a minute, I will give you an idea one more thing, because in case of the ROM you need to store the in the data also. So how you can store, just a minute. So there is a file test.mem, you can see from here itself. So what we are doing, we have specified that these values are stored. So you can see that they all are in a hexadecimal. So this is first part. So you can see this 00 refer the first 8-bit, then second 8-bit, then third 8-bit. So total number of 8 bits are 1, 2, 3, 4, 5, 6, 7, 8. 16 8-bit inputs, values are there. 16. Okay. So this kind of file you can design. Just a minute. And TKGate. So here, let's say 8-bit. 8-bit here. Now 16 values, yes. Now instant property, This is okay. Delay. Yeah, memory file. You have to specify the which memory file we want to use. So browse test.mem file. The name is test.mem file. Open it. Okay. Let's run. Run. So let's say we want to pass the 2. So at the place 2, what values is available? You can see from here itself. Just a minute. 2 means 0, 1, 2. This value is there. I can try the other one also. 0, apply. You can check from 0. When you apply 1, like in that way we can run. So all these values we have to specify here and then run it. Okay. So I will share you all these things with you, and then I will share the assignment also. Okay, thank you. If you face any difficulty, you can write the mail to me. Thanks.